Okay, so today we are going to start talking about something called the line of best fit. So, the line of best fit is oftentimes used when you have a scatter plot. So, a scatter plot is a graph that relates two sets of data. So, basically, all that means is it's data you could get from an X and Y table. It's nothing new that we haven't seen before. Um, and this is seen more with like realistic data. So if you were to like survey people or things like that. So when we do things like that, as you can see down here, it doesn't always go in a perfectly straight line. So we have to think about the different types of correlation that we might have. So all that means is the data going in a negative way? Is it going in a positive way? Or is it not going any type of way at all? So this first set is a negative correlation because you can see all the lines kind of follow how that arrow is going down like that. So that is a negative correlation. On the second one, there's really nowhere I could draw a line that would go with any pattern on here at all. So that's no correlation. And over here, we can see all the data is kind of trending up. So that's a positive correlation. So if it's trending down, it's negative. If it's trending up, it's positive. And if it just looks a hot mess like that middle one, then there's no correlation. So the line of best fit is a line we put on a graph to show somewhat of a relationship between the X and the Y sets of data. There is no single line that is going to hit every point or represent the entire set of data that you have. So, what you have to do is kind of eyeball it. The rule of thumb is you want to try to have an even number of points above the line and an even number of points below the line. So, in order to do that, sometimes you might not even hit any of the points on your graph. You're, like I said, you're just kind of eyeballing it. It's not an exact science. So, this is something to think about. So, here we're going to select which one is the correct line of best fit. So, looking at our first two options here, I have A and B. If we look at A, we're hitting a lot of the points that are on the bottom of that set of data. We're not really hitting a lot on the top, and we're not kind of going through the middle. So, you kind of have to think about it as going through the middle of your data. So, here, we're kind of just going through the bottom. We're not anywhere close to up here. Now, down here, we're kind of going through the middle. We've got 2 on the bottom, 3 on the top. It's about the same number. So B is going to be the right one here. It makes it a little easier. It's a little more accurate. It hits more points. Whoops. So on our second set here, we are going to have A as the right answer. So you can see B kind of ignores all these points out here and just goes straight down. So even though we're going through the middle of this top half, we just kind of ignored the bottom half, whereas A is kind of going through the whole thing. So that's why we're going to choose A. On our second set here, we can see A is really only addressing the top half, not the bottom. Whereas B, we've got about the same on top as we do on the bottom, and we're going right through the middle of the scatter plot. So that is going to be the right answer. And then over here, we can see that we really don't have any type of correlation. There'd be no correlation here. And when that's the case, you just do not draw a line of best fit. So B is going to be the correct answer in this case. So here we are going to say if the slope would be positive or if the correlation, is positive or negative. So on 7, we can see that data is trending up. So that is going to be positive. So I can draw a line trending upward through that data and see that it is going to be positive. On number 8, it looks just like a mess. There's not a set pattern there. So that's going to be neither because there's no correlation. Looking at number 9, our data is trending down. So that is going to be a negative slope. And number 10 is kind of hard, but it is still going to be negative because it is still kind of trending down. So now we're going to practice actually drawing a line of best fit. So the first thing I'm going to do is fill in this XY table. You do not have to do this. It's not a necessary step. So if you do not want to write one of these, you don't have to. By any means, do not feel like you have to because you're not really going to use the points anyways. We're just going to try to eyeball a line. And I'm going to show you how to do that. So I can tell that my data is trending up. So I know my slope is going to be positive. And I'm not going to lie to you all, these are super hard to draw on my iPad. But I'm drawing a line. You can see I have 2 on the top and 1 on the bottom, and I'm hitting a lot in the middle of the data. And so here's the thing. We will most likely, a lot of us, get different answers for these. So basically, the rule of thumb is as long as you're within 0.5 either way, you have the answer right. So just keep that in mind. As long as you're within 1/2 of the answer, you still get it right. And sometimes, depending on the situation, so since we're doing ours on the computer, if you're within 1, I'm going to count it right because it is kind of hard to see. So just keep that in mind as you're working through this. You're not always going to get exactly the same answer. So sometimes you have to go with what's close. But the good thing is, when they give you line of best fit questions, they're not going to give you 4 answers that are all super close to each other because it's impossible to accurately get a line of best fit unless you're using specific software on a graphing calculator. So for this case, since we're just having to eyeball it and do it by hand, it doesn't have to be super exact. So my slope is positive. I've drawn my line. I'm going to pick 2 points from my line. And from there, I'm going to find the slope. So I draw my triangle. I see I have a run of 4 and a rise of 3. So my slope is going to be 3/4 or 3/4. And my y-intercept, you can't see it super well, but I can see that it kind of goes through 0. And it's not going to cross the y-axis until around -1. So I'm going to say that it's approximately -1. So then all I do is plug this into y equals mx plus b. So I'll have y is equal to 3/4 x minus 1. And then we're going to do the same thing down here. I'm just going to fill in that table. Like I said, do not worry about doing that unless a question specifically asks you to. In here, I can see that my data is trending up again. So I know that the slope is going to be positive. And if you look, when I'm drawing my line, I'm trying to keep around the same number above and below. So I've got 2 above and 2 below. And it doesn't always have to be exact. Sometimes you might have 3 on the top and 2 on the bottom, but you never want to have a situation where you have like 10 points above the line and only 1 point under the line. That does not work. So just keep that in mind. So I can tell that the slope is going to be positive. I picked 2 points from my line I just drew. And I see that I have a rise of 4 and a run of 2. So my slope is 2. And I can see that I went too far. And I can see that my y-intercept is around 2. So my equation is going to be y is equal to 2x plus 2. So here I'm given the table and I have to make the graph. So all I'm going to do is plot these points on my graph, which we all know how to do. So I'm not going to spend a lot of time on that. So now that I've got all of them plotted, I can see that my data is trending up. So my slope is going to be positive. And you can see I have 3 above and 3 below. So I'm going to pick 2 points. I'm going to draw my line. I see that I have a run of 3 and a rise of 4. So my slope is going to be 4/3. And my y-intercept again is going to be about -1 because you can see right here where it would be crossing would be about -1. So I'm going to have 4/3 x minus 1 as my equation here. And then we are going to skip this one. Okay. So the reason we skipped that third one is because I realized that I did it wrong. So I'm going to be making a follow-up video not a follow-up video. In our examples we go over on Wednesdays and Thursdays, I'll be sure to go over that problem. But I just realized I made a mistake, so I didn't want to try to correct it while I was playing the video. So here, I'm going to draw my line. I have 2, I'm telling you guys, this is something, a topic that I really did struggle with a lot in school, and still struggle with today, just because I find it difficult. So you can see I touched 3 points, and then I have 1 above and 1 below, and my data is trending up. So I realize that I have a positive slope. So it's important to note here that our y-axis is no longer changing by 1. It is now changing by 2. So we haven't done a slope problem where our y-axis has changed by anything other than 1. So when I draw my triangle here with my 2 points, I see that I have a run of 3. And this normally would be a rise of 3, but we have to think we're going from 12 all the way, or not 12, 10, all the way up to 16. So that's really a rise of 6. So that is where it's important to make sure you are paying attention to what that y-axis is changing by. So even though we're only going up 3 blocks, we have to remember each block actually represents $2 instead of $1. So each time we go up, we're increasing by $2. Okay, so our slope is going to be 2. And my y-intercept is approximately 4. So my equation is going to be y is equal to 2x plus 4.